right. Well, I'll turn this over to you.
Okay. All right. Well, hi, everyone, all over the world, online. Welcome. Shame we can't meet in person this year for EuroPython, but this is, I must say, kudos to all the organizers. I've been supremely impressed by the conference, and from the back end of it, from the speaker's perspective, really impressively organized. As I said, my name is Reuven Lerner. My talk is how to sort anything. A few words Jason also said. So I do corporate training. I have all sorts of online courses. I just published my first book with Manning, Python Workout. I actually have it in hardcover. Remember hardcover, folks? That's right. I have my weekly Better Developers newsletter as well, which I think currently has about 18,000 subscribers with a new article about Python each week. So, sorting. Sorting is important. You might say it's sort of important. Okay, get used to my humor, folks, for the next half hour at least. Sorting is important. Sorting is something that we do all the time for a whole lot of different reasons and in a whole lot of different ways. So why do we want to sort? And mixed in together here, I have some more abstract ideas and some more concrete ones. So we might want to display our data nicely. Let's see all of our data in calendar order from January through December, or order of years from earliest to latest. Maybe I want to make my messy data slightly less messy. I want to sort of be able to look at it and understand what's going on. I often want to find the largest or the smallest value in a collection. Right? What was the smallest amount I made the smallest amount that I made in the last year, or the largest amount I made from purchase in the last year? We see which products sold best or worst. Which supplier's proposal, assuming you're a company, you've got a bunch of potential suppliers, which proposal will cost you the most? And then if you're using Waze or another sort of GPS system, you want to find the closest gas station. And do you want to find the closest one? Do you want to find the cheapest one? Do you want to find the one that will take you the least amount of time to get there? These are all things we do with sorting. Maybe you're watching Netflix because you haven't left the house in 6 months and you want to find a film similar to the one you've just watched. Well, there you go. We can use sorting for that. Maybe you're on Amazon and you want to find, or they want you to find, products similar to the one you're looking at. All of these involve sorting. And Python actually makes sorting really easy. If you have a list, you can use the sort method. So basically, I can define my list here. My list is 10, 5, minus 3, 7, minus 2, 4. And then I'm going to print out, I'm using the cool Python 3.8 f-string syntax, where I can have inside the curly braces variable name equals sign. And this will print out as variable name equals and then its value. So I'm going to print out the value before sorting. Then I'm going to run my list.sort, and then I'm going to print out the value after sorting. And sure enough, I get, what do you know, before I sorted, the list is exactly as I defined it. And after I sorted, it's a numerical increasing order. Okay, so far so good. Well, there are a few things to realize about list.sort. It's a list method, so it's only going to work on lists. If you want to sort something else, tough luck. You got to turn it into a list before you can actually run sorting. It sorts from smallest to largest. That's by default, and we'll see how we can change that a little bit. And here is one of the most important things. It changes the list object itself. So what we see here is my list is, again, same exact values. Get used to them. We're going to see them quite a bit. And then I assign a second variable here, also my list, to be equal to my list. What this means is we now have two variables referring to exactly the same list. That's fine. That's not a problem in Python. We can do that. And then I'm going to print out what is the value of also my list, meaning the second variable, but I'm going to sort my list. So I'm going to sort via my list. What's going to happen to also my list? And the answer is, before also my list is they look exactly the same. And after, they also look exactly the same. That is to say, there's no difference between sorting my list and sorting also my list, because you're not really sorting the variable. You're sorting the list that the variables refer to. And so this is one of the problems with using the sort method on lists, that yes, it modifies the list, but yes, it modifies the list, which means all the references to it will see that. Another problem with list.sort is that it returns none. This is a common convention in Python, especially the standard library, that if you have a mutable data structure and you run a method on it that modifies that mutable data structure, then that method will actually return none. It won't return the data structure itself. So I see this all the time in my courses. People do this because it feels sort of natural. So we define my list. We're going to print what it is before. And then what am I going to do here? So remember that in assignment, it's always right side before left side. So on the right side, I'm going to say my list.sort. That will actually sort the list. It will be sorted. But the return value for the method is none. And thus we have assigned none to my list. And so the output for this is going to be before it's our list and after it is none. So if you're short on memory, this might be a great way to like solve those problems. Otherwise, though, not a good thing. So what can we do to avoid this? Well, we can avoid it altogether. We can ignore it altogether. We can use the sorted method. I'm sorry, sorted function. And sorted is a function that comes, it's built in. So it's in the standard library, it's built. You don't need to import anything to work with it. It works with all iterables, not just with lists. So you want to sort a tuple, you want to sort a dictionary, you want to sort a file. You can use all of those with sorted. Now, sorted will always return a list, and it'll always return it by default, sorted lowest to highest. And here's the greatest thing. It does not modify the source data at all. So if I want to use it, what can I do? Well, let's start off with my list again. And I can just, I don't need to do a before and after. I can just say print sort of my list. And then I'm going to print my list afterwards just to compare. And sure enough, the sorted of my list shows me these sorted values there. But afterwards, my list is still the original values, meaning sorted will return a new list, and I haven't changed my original list at all. This means that I can sort tuples. How can I sort tuples? You can't change tuples, right? Because we're not changing anything here. We're just going to get a new list back based on the tuple. If I sort a dictionary, I'm going to get the keys back in sorted order, but I'm not touching the dictionary, and so on and so forth. Now, how is all this being sorted? Well, because many people ask me, like, is it using quick sort? Is it using merge sort? Well, I'll give you a hint. The sort algorithm was actually created by Tim Peters, and that's why it's called TimSort. And in case you think that TimSort is this weird esoteric Python thing, it's not anymore. TimSort is now apparently the default sort method used in Java. Now I know Java is like not going anywhere, but it gives credence to the fact that we've got a language here that's actually working, sort that's working very well. And TimSort is this interesting combination of merge sort and insertion sort. Where basically what's going to do is it's going to assume, well, it assumes in general that your data is not completely 100% random, that if it's coming from the real world, it's going to have some natural runs. It's going to have some sequences that are already stored inside of it. So it's going to take advantage of that. It's going to create a few runs, hopefully some of them being natural runs. They'll merge them together. What happens if there are no runs? Well, that's going to create a run. How's it going to do that? Insertion sort. Insert, 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 merge, insert, 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 merge. And that's how TimSort works, and it works pretty well. Well, in order to do both the insertion and the merging, it's going to need to do some comparisons. And so TimSort needs to know, is A, given two items in our list, in our tuple, in our whatever, given these two items, is A less than B? Is A greater than B? Or is A the same as B? And so TimSort's going to rely on this. Now, before we were sorting a list of numbers. Well, a list of numbers is going to work fine because numbers know less than, numbers know greater than, numbers know equal, trivial. That's great. But what if we want to get a little more interesting? What if we want to sort a list of strings? So here I'm creating a list of strings. I have my string. I run .split on it. And split, of course, returns a list of strings. Basically, it breaks up our string along white space into a list. So words here is a list of strings. And if I say print sorted words, I'm going to get out the words sorted from lowest to highest. Well, lowest to highest, what does that mean? Well, we as humans would think of it as in alphabetical order from the earliest in the dictionary to the last in the dictionary. So how is Python doing this? Well, it says, well, we can compare a one character string, right? Remember, there are no really characters in Python, it's all strings. So one character string can be compared with less than or greater than or equal. And the comparison is done based on the Unicode code point for that one character string. Now, in case that sounds super like fancy and difficult to follow, you can think of it, if you're a dinosaur like me, as just ASCII values. That basically every character is a numeric value. So little a comes before little j, comes before little z. So it will sort those alphabetically. Aha, but remember that in Unicode and in ASCII, capital letters come before lowercase letters. And we'll talk about this a little bit later. So things that begin with a capital letter will come before things that begin with a lowercase letter. In any event, so Python first checks, given this, Python first checks the first character of the two strings. So we want to see, I have two strings, word one and word two. Which one comes first? So we're going to check the first character, and we're going to apply this rule with a less than rule, or the greater than rule, right? Let's compare their code points. Let's compare their ASCII values. And we'll know then which one comes first. That's fine if we have a one character string. We compare index 0. What happens if that's not obvious? What happens if they are the same? Then we go to index 1. What if those are the same? We do index 2. What if index 3? Until we find a difference between them. This is how we know then if two strings are equal. If they're equal, then all the characters are the same. And, well, what do you know? Neither comes first. This also means, though, If one is a substring of the other, we're going to return the shorter string first. So if you have find and finding, so find is going to come first because it's shorter. And if this sounds familiar to you, this is how we look things up in a dictionary, as I mentioned before. We first look at the first letter, second letter, third letter. We can alphabetize things in this way. The cool thing is that Python does this not just for words, not just for strings, but does this for all sequences. And so when I want to sort a list of strings, it's going to use this dictionary, start index 0, then index 1, then index 2 formula. What about list of lists? It'll also do that, index 0, index 1, index 2, and tuples the same way. And lists and tuples implement less than, greater than, equal in exactly the same way as well, where they're looking first index 0, then index 1, index 2, and so forth. Let's just check this. So if I have two lists, list 1 and list 2, and I have 10, 20, 30, and then 10, 20, 15. So Python is going to say, if we ask Python, is list 1 less than list 2? It'll say, no, it's not. Is list 1 greater than list 2? The answer is true. Why? Well, check index 0, they're the same. So let's check index 1, they're the same. Check index 2, up, list 2 comes before list 1. Thus, list 2 always comes before list 1. List 1 comes after list 2. What if I want to sort a list containing different types? So here I have my list is 20, B, A, 10, 30, and let's print sorted on my list. Fantastic. Oh, no, it's not. We get an error. And the error we get is type error. Less than is not supported between instances of str and int. Meaning Python is saying to you, hey, dummy, I don't know, if you give me a string, you give me an int, which is supposed to come first? I have no way of understanding their knowing that. Now, those of you who have used Python 2 might know that this actually did work in Python 2. You were able to use less than, greater than, and equal in Python 2 between strings and ints. This was changed in Python 3 because it was such a hard thing for people to understand, because it wasn't comparing them in a numeric way. It was saying all strings come after all integers. Doesn't matter what their values are. So if you knew the Python internal sort order for different types, it was fine. But clearly no one wants to keep that in their heads. And so in Python 3, they said, if the types don't know how to compare themselves to each other, that's it, we're going to give you a type error. So don't try to do this, or try to do it if you know that it will not work. Okay, what if I want to reverse the direction? What if I don't want from lowest to highest, I want from highest to lowest? So I'm going to say my list equals 20, 30, 10, and now I'm going to pass a new parameter. I'm going to say reverse equals true. And reverse equals true basically just swaps the order. So basically, instead of being lowest to highest, it'll be highest to lowest. And indeed, we see here that we get 30, 20, 10. So far, so good. But what if I want to sort a list of words? Not the words themselves, not alphabetically, but by their lengths. This is where things get really interesting and really cool. We no longer want TimSort to be saying, is word 1 less than word 2? Rather, we want it to be saying, is the length of word 1 less than the length of word 2? Right now, we don't want to sort the lengths here. Sometimes when people see this sort of problem, they say, oh, what you want to do is use like a list comprehension, turn all the words into their lengths, and then sort those. No, no, no. I still want to get back a list of words, but I want to get back that list of words, that list of strings sorted by length, right? It's like lining up children in a school by birthday or by height or something, right? So how can I do that? Well, we have the key parameter, the sorted function, and by the way, the sort method as well in lists, allows you to define a key parameter, and it takes a function. And if we then say key equals f, it's going to say, oh, I'm going to compare not a and b, but f of a and f of b. And so if I want to sort the words by length, I can call sorted with key equals len. Let's see that. So here I have my words, and I'm going to say print sort of words, key equals len. Notice I'm passing a function as an argument to the key parameter, right? And this is only possible because in Python, functions are nouns as well as verbs. Functions are objects just like all other objects, except they have this added bonus, you can run them. And sure enough, now we get our words in increasing order by size. So what else can be a key function? What can I set it to be? Actually, anything. Anything can be a key function in Python, so long as it takes a single argument and returns a comparable value. Returns a value that could be compared with less than and greater than, for that matter. So here's some examples. If I say sort of words, key equals length, just like we did, I can sort the words by length. I'm using length to sort the words. I can also say sort of numbers, key equals ABS. ABS is the absolute value, so I'm going to sort my numbers by absolute value, ignoring whether they're positive or negative. I can say sort of words, key equals stir.lower, and here's that case sensitivity that I alluded to a little bit earlier. Basically, if I run stir.lower in a string, I'm going to get back a new string, which is the same as the old one, just all in lowercase. So this allows me to compare the words without taking case into consideration, meaning it's a case-insensitive sort. Now, notice, we can pass a method by passing as the class attribute. So I'm not going to say s.lower or word.lower, assuming that s or word would be the instance. I have to pass it according to the class. Now, a really common mistake that I see people make is they put parentheses after the key function's name. They're so used to calling functions. So they do something like this. We're going to say sort of numbers key equals ABS parentheses. Don't do this. Don't do this. First of all, it won't work because ABS requires an argument. And here you're going to get an error saying there's no argument. But second of all, remember that key expects to get a function. It doesn't expect to get the result of a function. So you really want to say sort of numbers key equals ABS just like that. And we will indeed get back the numbers sorted in that way. What if I want to sort a list of lists? Well, let's say I want to sort them by length, shortest sublist, and then biggest sublist. Sure enough, I can say key equals len. That's right, just like I did with strings, because len works on strings and lists in the same way. What if I want to sort by the sum of numbers? Well, I can say key equals sum. And then what's happening is we're going to sum up each of these sublists, and then we're going to order them from lowest sum to highest sum. But I can do even cooler things if I write my own custom key functions. As long as my function takes an argument, as long as my function's return value is sortable, comparable, then we'll be fine. And remember, the value does not need to be the same type as the input. So I can sort strings by their lengths because the len function returns an integer. So let's say a few examples of this. So let's say I have a list here of numbers, 500, 2,100, 130, 1,040. And now I'm going to say def by digit count of n. Now, this is going to be my key function. This is the function that I'm going to run on each element, and based on its output, I will know, or TimSort will know how to order things. So what are we going to do? We're going to take a number, turn to a string, get its length. And now I can say print sorted numbers, key equals by digit count. Now I should add something here, which is my personal convention. I invented myself, I think, I hope, is to always say by when it's a key function. So I can then say I'm sorting by this or sorting by that. You don't have to do that, but you'll be really cool if you do. Obviously, your friends will love you as a result. So what happens if I do this? Sure enough, I get 130, 4,500, 100, 2,000, 1,000. I've now sorted the numbers by their digit count. But you might be saying, wait a second. Numbers are always sorted by their digit count, and these are not sorted numerically. What the heck is going on? And the answer is that TimSort is what's known as a stable sort. That does not mean it only sorts horses. A stable sort means that if two items in the original list, all right, if two items in the original list will have the same sort value, they will stay in that order in the output list. So because 500 came before 100 here, it will be before 500 before 100 in the output list. And because, well, I guess 2,000 came before 1,000 here, it's also going to be there as well. So you have to remember it's a stable sort. Normally it's a great thing, but you can be a little confused and surprised here. What if I want to sort the sublist by their means, right? By the new mathematical averages there. So what we can do is we write key function by mean, and it'll take one list. And it's going to return the sum divided by the length. And now I can print sorted numbers key equals by mean. And sure enough, we get them sorted by their means from the lowest mean to the highest mean, if you know what I mean. All right. What if I want to do something even a little crazier? I want to sort the number of vowels per word. So I'm going to have here words equals this here is a fascinating, scintillating text split. And what am I going to do? I'm now going to define a new key function by vowel count. And I'm going to ignore the print for a moment. We'll talk about that in a second. Total equals 0. We're going to iterate over each. We're going to iterate over each letter in the word. We're going to take the word through to lowercase. We're going to count up the vowels and return that. And sure enough, we can do this. But this print here, why did I put this print here? If I put the print there, then I will see. Don't do this in production, right? Don't do this in a real system. But for debugging and testing, it's great because I can see exactly which words are being passed to by vowel count. And so if I run this now, we will see print sorted words key equals by vowel count. Look what I get. It's going to show me all of the words that were checked. And it shows that each word was checked once and once only. And then basically we'll see that the words are indeed sorted by the number of vowels in them. What about sorting file names by file length? So I'm going to get a little help here. I'm going to use the glob module or the OS module. And I'm now going to get a bunch of, what? Oh, sorry. Okay, all right, so sorry about that, folks. So by file length to file name. All right, so what are we going to do? We're going to get a file name, and we're going to run OS stat on that to get its size. Fantastic. And now I'm going to get all the text files in the current directory. I'm going to sort them by file length. And you don't know these files, but I promise you this actually happens to be the case. It's from the smallest file to the biggest file. I can sort the file names by the file's file count, right? I can use the same sort of thing as I did before, but now I'm going to go through the entire file, line by line, go through each character in each line, one by one, count the number of vowels, and then we'll see here that I can actually count or sort the file names by the vowel count. Well, let's get even fancier. What if I have a list of dictionaries, right? So here I have some people, I have my children and me. They enjoy appearing in my slides, or so I think. And we have first names, last names, and ages. So can I sort this list of dicts? Nope, can't do that. Why? Same sort of errors we saw before. Python does not know how to use less than between instances of dict. It doesn't know how to compare dictionaries in this way. But we can use a key function. So let's say I want to sort these people by age. I'm going to define a key function by age of D. And then I'll just return the age value, the value sorted with the age key from there. And now if I say print sorted people, key equals by age, sure enough, I get the list of dictionaries back, and they're sorted by age. What if I want to sort by multiple keys, like last name and then first name? Well, then what I'm going to do is I'm going to have the key function return a tuple, because Python knows how to sort tuples. And so what I can do is I can say return by first last, return first the last name, and then the first name. And sure enough, if I now say print sorted people, key equals by last first, what am I going to get? I'm going to get the people sorted first by last name, then by first name. So you'll see here I come first because my last name is shorter, and then my children all have the same last name, but then sorted by their first names. Pretty snazzy. Now, the thing is, why should I write a key function? I want to be lazy, right? I can use lambda. Lambda creates an anonymous function, and as long as you are passing a function object to the key parameter, you're fine. So here I'm going to use lambda, and it's going to do exactly what I did before. It's going to take a dictionary, and it's going to return a tuple with last and then first. So it will sort in exactly the same way. But I can do it even better. A more Pythonic modern approach is to use operator.itemGetter. And it's a function that returns a function. So if I want to sort people by age, I can just say, hey, key equals operator item getter of age. That will return a function that will indeed invoke square brackets age on each element and thus allow us to sort them that way. And we can even do better or differently. We can say key equals by first last to sort by last name then first name. Or I can say operator item getter last and first, and then it's first going to do last name and then going to do first name. Exactly what I want. Well, what if I have my own class? What if I want to sort objects? So here's a class person, exactly the same data as before, just in a class rather than a list of dictionaries. And now I have a list of instances of person. And if I want to print sorted people, what am I going to get? That's right, another error. Why? Because less than doesn't work on this. How are we going to change that? We're going to implement less than. That's right, the dunder LT method allows me to do that. And now I might as well add EQ, dunder EQ, to provide for equal as well. And if I do that, now actually I can sort. You want to sort by last name and first name? Fine, we can do that too. But wait a second. What about if I want to sort by, I want to check greater than and equal? Because we've defined less than and we've defined EQ. What if I try to say people 1 is greater than equal people 0? No, I won't do that. Because maybe I've defined less than, but I've not defined greater than equal. What are you talking about? This is where total ordering comes in, folks. I can use from functools, the functools module, I can use the total ordering decorator. And total ordering will use LT and use EQ and build out all of the rest of the comparison methods automatically on your class. Pretty darn cool. So now if I say, hey, is people 1 greater than equal to people 2? Oh yeah, that's fine, that's true. But why should I work so hard? In Python 3.7, we introduced data classes, and they reduce our code for creating classes by a lot, and they automatically handle sorting. Watch this. From data classes, import data class. And now here's my class. At data class, order equals true, class person, firster, laster, age int. So I need to import data classes and data class. I need to apply the decorator. I need to say order equals true. That doesn't happen by default. But then it's going to sort according to these attributes. So how's it going to sort them? Let's take a look. Here are my people, and let's print them out. And we're going to get, that's not sorted at all. Or it is sorted, but how? Guess what? It's sorted by first name, then last name, then age. Why? Because that's the order I specified the attributes in. So let's redo this a little bit. Let's say I'm going to have now the attributes be last, then first, then age. And of course, because the order changed, I'm going to need to change how I create my list of people. And now when I sort it, sure enough, it's going to sort first by last name, then by first name, and then by age. So it works just great. So Python sorted function lets you sort anything. And the key, is the key function, right? Any function or method that takes a single input and returns a sortable output is fair game. You can write your own, you can use lambda, you can use operator item getter. Classes are sortable. All you have to do is define a few magic methods. And if you use data classes, it's even easier than that. Cool. We covered a lot of stuff. I'm very happy in my few remaining minutes to answer questions. And let me know.
Thank you so much. That was actually very insightful. I enjoyed that a lot. I wish I could get this. Here we go. Here we go. I just have to hit this button. There we are.
I thought there was noise on the line for a moment. Thank you. That was very impressive.
So yeah, I actually do have a couple of questions here, and we'll see how many we can get through. One person, Vinicius, says, is sorting on the database faster or more efficient?
Oh my God, if you're using a relational database, please use the database to do your sorting. It's going to have, like, unless it's a really bad database, but like it's going to do things for two reasons. First of all, it's implemented in C almost certainly, so it's just going to run faster. And second of all, it's probably got all sorts of like extra indexing thrown in there. But the third reason is you don't want to pull all the data from the database into memory in Python, into Python data structures, and then sort it. It's much better just to get it sorted in advance.
Okay. Pascal says, awesome. Reuven, do you know if key functions can be used to sort data frames as well?
Ooh, yes, but not in exactly the same way. So like pandas data frames, they're sort of like Excel spreadsheets, although soon Excel will be saying it's sort of like pandas, right? But basically, you can sort in all sorts of different ways. I know that you can apply functions there. I can't remember if the syntax is exactly the same. It's not exactly the same as key functions in sorted, but it's really close and similar.
All right. Israel asks, how would you put multiple sort options on a class or a data class?
I don't think there's a good answer to that, unfortunately. I mean, you would need to really use a key function there and sort of, you might be able to have special methods, right? Because you can define the methods on as many methods as you want in your class or even on a data class, but then you would have to specify it. Sort is going to assume that whatever the object's less than, greater than, equal to. I mean, I guess if you really wanted to be sort of weird, you could have like some sort of attribute that you could switch off how you want to do sorting, and then the LT, EQ, and so forth would switch off accordingly. But I don't know if I'd recommend that.
Okay. And then actually, one more I have from somewhere else, and if anyone else has any that they want, if they want to ask anything else, there's the talk sorting anything, and you can ask additional questions there and chat with Reuven. So the last question then is, and it's a little bit outside the realm of Python, but have you heard of dual pivot quicksort?
I have not, but now I'm going to write it down and find out about it.
Excellent. All right, so I think that's all we have. So once again, thank you so much, Reuven, for that.
Thanks, everyone.